Hey everyone, welcome back to the On Track podcast. Thanks so much for joining us again today. As usual, I have another fabulous guest for you today, who is Kent Bayless, who's a senior consultant of Epic Front-End Engineering. He's also the co-founder, and he's here to talk to you about strides that are happening in the industry that are around the digitization of front-end engineering for PCB fabricators. Kent spent 35 years working for such global giants as VS Systems and TTM, and he worked on something called Global Seamless Transfer, which helps standardize that process. There's a lot for you to learn here, a lot of money to save, a lot of headache to save, and so I hope you'll enjoy this conversation with myself and Kent Bayless. So lean in, enjoy. I'll see you on the other side. Welcome to Altium's On Track podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Hey, Kent, thanks so much for joining us today. We look forward to this conversation.
It's great to be here, Judy. Thanks for the invite.
Yeah, it's my pleasure. So you and I met recently, found out we had a lot of friends in common. And like me, you've been around the block a little while. And tell us a little bit about your front-end engineering and why that's such a pain point to design engineers and OEMs that are some of our listeners here today.
Yeah, so I've, like you mentioned earlier, I've been 35 years in the PCB industry, most all of it in the front-end engineering, and spent an extensive amount of time, integrating new, better software applications, of course, driving a lot of software automation, all in the effort to improve productivity, improve quality. And probably the last couple of years, I came to a conclusion that it's irregardless of what we do, we're still, the industry is still collaborating with one another using unstructured data packages. We're continuing to send Gerber fabrication drawings, which in turn really just drives an extensive amount of labor tasks, administrative tasks, high labor cost. And so really the focus probably my last couple of years is, okay, what can we do to take this unstructured data and put it into an intelligent attributes or intelligent data and create a data-driven process, advanced automation? How do we reduce the human interaction with the software applications? And, it's all about how do we improve productivity? How can we collaborate with one another more efficiently, reduce the NPI cycle times, and just make a better process from design to manufacturing altogether. So,
well, along those lines, here at Altium, we've heard from some of our friends on the front-end engineering side some statistics where they think 90 to maybe 100% of jobs go on hold once the design engineer or OEM hands those off to, say, a fabrication or their EMS provider that in turn shares that with their fabricator. So is that a true statistic, or have you ever tracked that? And, what do you think the numbers of the jobs that go on hold right after the handoff?
No, absolutely. I would say for the best part, 100% of all design packages, whether it's an incomplete data package, their design anomalies, either it's unmanufacturable or it requires some enhanced editing, which you require approval. And so therein lies, even more of a situation where we spend an extensive amount of manual data entry, administrative tasks, processing and preparing the data. It goes on a TQ hold. We send this technical query to the customer. They make some changes. They send the data package back to the PCB fabricator, and virtually we're starting the whole manual process all over again. And And it's just an inefficient way, and it's been going on. I mean, we're still transferring and exchanging data packages like we were in the 1980s or earlier, for that matter. So you throw in the technology variables of today versus 30 or 40 years ago, and then there's just all those other factors that come into play on how we're going to manufacture it. So yeah, absolutely. I mean, it's a lot of back and forth and a lot of non-value added time that we're focused on eliminating here, and how can we become more efficient as an industry, right?
Well, and the other variable is, that over time, back in the 80s, a lot of, say, design engineers were drafters that morphed into really gifted and capable design engineer. But now the engineers of today that are, whether they're a one-man shop or working for a large OEM, a lot of them never been inside of a board shop or understand what some of those blockers are. So I assume that you've noticed over the years as more EEs are involved, that disconnect, no fault of their own. It's just PCB design is not taught in university.
Yeah, absolutely. I mean, I think nobody really understands what happens in the front end engineering. I mean, even within some companies, they don't know what goes on in the front end engineering. They know data goes in there and tools go out that's released to the manufacturing process, but what all happens and occurs during that process is pretty much unknown. I mean, it starts at quote. People are reading documents, they're reading specifications, they're manually entering information. An order comes in, it goes to a pre-CAM process. They now need to deal with the Gerber data. They're rereading the same fabrication notes, re-entering all this information manually. Basically, again, we're talking about an extensive administrative task. So you've got methods engineering. They're in turn reading the fabrication drawing, entering the information, all the product attributes. That's where it goes on a technical query hold. Send the new data package back, goes through the entire process, and we haven't even got to the CAM process at this point. So it's software applications have improved over the years. For sure, certainly from, I was on an Image 2002 Optrotech CAM system back in the mid to late 80s. Certainly the CAD design systems, the CAM applications have greatly improved, but it's still a very labor intensive, heavy administrative task process. If we can go and look at, first of all, Epic Front-End Engineering is focused on, well, how do we streamline that process, right? How can we make it more of a data-driven process, reduce the human interaction? What I'd like to see is engineers validating versus doing.
Yes.
And that's our ultimate goal, right? It's all about productivity, efficiency, improving the quality of the tools that are getting released to manufacturing. Now, in parallel with that, the exciting things that are occurring in the industry is and I've been patiently waiting, of course, I've been involved with it for 20 plus years now, is IPC 2581.
Yeah, we've been talking about 2581 for at least 10 years, right?
And I'm seeing several OEMs, large CAD software companies adopting that, and it's growing. It's certainly the catalyst, as I like to say, to driving exchanging of data packages in an intelligent format. So, for example, and I've had these conversations with, several large OEMs. It's like, we don't need a 15-word sentence on a PDF fabrication drawing telling me what the surface finish is. Just put it as an attribute inside the XML file, which is basically the structure of IPC 2581. And then that information can easily port to our quoting systems, our engineering applications. It's very clear. You can put everything from surface finishes to solder mask type, color, all the drills, the tolerances, the impedance requirements. And everybody, virtually everyone I've talked to is very excited about that, and they want to get to that point. So we're at a revolutionary, point in the industry, and if we can get more companies adopting that, and using the full capabilities of intelligent data packages, I mean, it's just going to be a win-win for everybody. It's going to streamline the process. All the smart engineering, as I like to call it, that EPIC is focused on, based on the unstructured methodology that we use today.
Yes.
That will just be easily, with that intelligent data packages of 2581, that'll be the foundation to just drive that automated, functionalities. I mean, virtually, that information is populating our applications. We're reducing the manual data entry. It'll be the foundation for basically semi-autonomous operations, right? It's reducing the human with the software. You eliminate the manual data entry, in many cases duplicate data entry that's occurring every day. There's just so many non-value add process steps in today's world that it'll be exciting to see once we really see a full adoption.
Well, it is exciting. And, to my earlier point about electrical engineers, they don't have time like we did in the old days, where you go survey the shop and you kind of go to school learning about how things are manufactured and, how to design for manufacturing. It's, at Altium, we've come up with this term called designing with manufacturing, right? The thing is that we get that handoff and that we speak a common language, right? Instead of like the Tower of Babel, where we're all speaking different languages and trying to get a reliable board out the back end,
Yes, exactly. Yeah.
Well, for our listeners, I'm going to put links to the IPC 2581 consortium webpage below, so you can learn more about that.
Yes.
If you're with an OEM, it'd be something great looking into. I'm also going to share the link to EPIC Front-End Engineering. And hopefully you'll be seeing Kent and some of that smart engineering start showing up on the front end of these shops, which, the combination of those two things would make your life a lot easier. And additionally, of course, Altium 365, we're trying to ease that same pain point. So Kent, give us an idea of the scope of the work you were most recently doing at TTM, because I think TTM is still the third largest global manufacturer of electronics and printed circuit boards. So how many plants were you trying to standardize in more this smart engineering sort of method?
There was about 14 PCB factories in the US, and probably it was 4 or 5, I think, that were remaining in the China operations. I was responsible for, integration, standardization, making us look like one company. We had one TQ format. My team was responsible for developing global solutions, basically. So we would develop automation or software applications, all in the effort to drive efficiency, productivity, in automation, and then share that across all the facilities. The last few years, my focus in particular was really starting to look at this smart engineering. What can we do to eliminate and make this a more semi-autonomous process? How can we utilize applications that will autonomously process, like, for example, in pre-CAM, there are software applications available in the industry today. We didn't have to develop it, but how can we adopt that? And then again, all in the effort to drive efficiency, productivity, improve quality. We looked, and I'm continuing to work with a company that has developed is one of the largest and best OCR engine in the world. How do we take a fabrication drawing? If we're going to continue to get these unstructured data packages in a fabrication drawing, throw them into an OCR application and teach it to extract all of the critical attributes, either for quoting or for engineering, for that matter, through the front end, converting that into an XML file, and then just port it directly and basically, again, engineers are validating versus they're not doing the manual data entry. And it was quite successful. Those are things that Epic Front-End Engineering is why my co-partner and I started Epic Front-End Engineering is okay, how can we take these what I call smart engineering, or that can drive the productivity improvements, and how can we share that with the rest of the industry, and harmonizing with the software applications and making them more efficiently, again, at the end of the day, intelligent attributes, data-driven processes, and reduce the amount of administrative tasks, which are just, excessive to say the least. So, at the end of the day, what do GMs and owners of companies want to do? They want to become more productive. They want to reduce labor costs, drive efficiency. They want to make sure the quality of the tools going out to manufacturing. So what are all the things that we can do more autonomously to drive that, and at the end of the day, increase their revenue and profitability of the company?
So Kent, give us a glimpse of what a world with smart engineering might look like for today's busy, OEM design engineer.
So, I mean, the biggest, this is not, it's not just, when we talk about IPC 2581, when we talk about smart engineering that we want to apply into the front-end engineering operations, I mean, it's a win-win for the industry. So this is not just about, at the end of the day, the PCB factory driving efficiency and productivity. It's all about NPI process. I mean, how many delays, how much days do we lose going back and forth on technical queries? We got holds. All of a sudden they're delayed for assembly on the product because it's delayed through manufacturing because we're going back and forth on TQ holds. A lot of the business models today is quick turns in North America and production offshore in China, for example. So typically it goes through a process here in the United States fairly quickly. And then all of a sudden it goes to a production where they want to get 99% yields over in Asia Pacific. And all of a sudden they have all these other TQs and stack ups or material changes and various other things. So, the 2581, again, I think is a catalyst for the future relative to exchanging data and streamlining the whole process, reducing all of this back and forth, non-value add steps, non-value add delays in the process. Mm-hmm. So it's a win-win at the end of the day. I mean, let's eliminate somebody having to read and interpret a note on a fabrication drawing and send it in a more intelligent format as an attribute that is very clear, it's very concise. And at the end of the day, it's all about reducing cycle times, holds on and improving the overall NPI process. So it's a win-win. This is, we're still, again, as I mentioned earlier, we're still exchanging data like we were in the 1980s, and I didn't even have a cell phone in the 1980s. I mean,
yeah, me neither.
Look at today's world, where we are today. A few buttons on Amazon.com and I got something being delivered to me. If I had to go in there and manually fill out a form and read and interpret and manually fill in this information, I probably wouldn't be shopping at Amazon, right? So that's right. It's an improvement to the overall industry, and that's just a win-win for everybody.
Well, I think it's really interesting and compelling, which is why I wanted to have you join, because there's, we're sort of in this period of they talk about across industries and this digital transformation. And I know for you and I, we're like, thank God this could come here. Yes. Because it's about darn time, instead of doing things like I said before, like Fred Flintstone, and talk about reinventing the wheel on every dang job. It's painful, and it causes so much pain to design engineers, and they don't always know why, and it just seems pointless. So I'm glad we're getting closer. I did see, as you mentioned, at IPC Apex a year ago, before we were all locked down, that there were a lot of OEMs really getting behind IPC 2581, and they had that whole line set up at Apex last year. So it did appear that it was getting finally some real traction across the industry. So that's exciting news.
Absolutely. I've been engaged with many of the customers that have made that full transition. I've been engaged with many of the OEMs that are in the midst of or close to transitioning. Um, and as that adoption grows, and then I would like to see, and I've had those discussions with the IPC consortium team, is adding more intelligence. Let's eliminate a fab drawing. Let's eliminate the fab drawing, put everything as intelligent attributes in there. There are tools and softwares and applications available then that can take that information, and all of a sudden we've got a data-driven process, semi-autonomous process. Everybody's more efficient, more productive, reducing eliminating all the non-value add times. So yeah, it's exciting. I'd like to see that adoption increase across all the industry, but like anything else, it takes time.
It sure does. For as fast as technology moves, it seems our industry is slow to adopt some of these things, but it does feel like we're making progress. Well, Kent, thanks again for joining us. And for our listeners, I'm going to put links through, like I said, to Epic Front Engineering's website. Kent is also just about to launch a new column in Printed Circuit Design and Fab magazine. I'll share that link as well, because he'll be sharing more of this sort of information over the coming months. And I hope you'll tap in and continue to learn about that. And hopefully this has been helpful to take some pain out of your process of getting your ideas to market. So Kent, thank you so much. I think what you're doing at Epic is going to be a real service to the industry. And as you sort of look to scale this across the industry and not just the large manufacturers you've had the privilege to serve. So thank you.
Thank you, Judy. It was great to be here, and we're excited about the future. So thank you.
Thank you so much. To our listeners, thanks so much for joining us today. We look forward to being with you next time. Meanwhile, please give us a like, a subscribe, give us a comment. What do you want to hear about next? We always love to hear from you. We appreciate you. We hope you have a safe and healthy week. We'll see you next time. Until then, remember to always stay on track.